the GCF of this, you would get 1. In other words, the only common factor among x squared and 3 here is 1. That's going to happen when you factor out the GCF. That's why it's also called the greatest common factor. What's left over, there's only a common factor of 1. And that's really what I'm saying here. So going through that slide, as you can see, since there's a non-zero constant term, right, we have to take m to be 0. Basically, there's no variables next to 3. Or if you want, you could think of this as 3 times x to the 0. Then the smallest exponent would still be 0. And you're still using this convention. X to the 0 is 1. Not only that, notice the coefficient of x squared is 1. Okay, but the only factor of 1 is 1 itself. So the only common factor among 1 and 3 is 1. That forces b to be 1. That forces b to be 1. So again, let me say it again. The only factor of 1 is 1 itself. And we know the factors of 3 are 1 and 3. So the only common factor, hence the greatest common factor among 1 and 3 is 1. So altogether we get 1. And again, it's no accident that we get 1 here because we factored out the GCF already. What's left over should have a 1. And that's really one of the notices on this page, on this screen over here, that the polynomial left over the terms will have a GCF of 1. And this is just something else I said before. If there's a non-zero constant term, that tells you the m has to be 0. The GCF can only be a number. And this is something else that we saw on the previous slide, that if you have a coefficient of 1, that's going to force b to be 1. Because the only factor of 1 is 1 itself. So the only common factor you can have is 1. And there's just some other stuff. If the polynomial has 1 as the non-zero constant term, that forces the GCF to be 1. So it's just, again, if you don't remember this, that's okay. I would try and remember it though. Mostly because it will save you time when you're factoring. So, okay. So now we have this. Let's move on and do another example. This will just illustrate what I said just now, that if the non-zero constant term is 1, then the GCF has to be 1. Mostly for 1, the smallest exponent of x is 0, right? Right? The smallest exponent of x we could take to be 0, right? You could think of 1 as x to the 0, and then you're using this convention again. Here, the coefficients of 4 are 4, 8, and we have a constant term of 1. But again, the only factor of 1 is 1 itself. So the only common factor is 1. It follows then that the greatest common factor, b, is 1, and m, we said, had to be 0. So we get 1. Okay. Are there any questions? Okay, so let's keep going. So now we're going to see another technique. We're going to factor trinomials that look like this. So here we have capital B and capital C. Those are just constants, they're numbers. Notice here we have degree 2. The leading coefficient is 1. So if you did try to find the GCF of this, you would get it to be 1. Okay. But you can see then that, well, let's see if we can factor it another way. They do go through the calculation a little more in depth than what I'm doing here. And really, it just boils down to this. You want to find two numbers whose product is C and whose sum is B. I called the two numbers little b and little d. So you want to find those numbers such that the product is C and the sum is B. Basically, you're going to fill in these blanks, so to say, where one blank above the other has the same term. That's what it boils down to. And once you get those numbers B and D, you're going to write this. Okay. All right, well, let's do an example of that. So let's suppose we want to factor x squared plus 7x plus 10. Notice we have this kind of trinomial. Trinomial, tri means three, like tricycle. So we have x squared plus bx plus c. We have this kind of trinomial, three terms, right? Degree 2, leading coefficients 1. So we want two numbers whose product is 10 and whose sum is 7. Product 10, sum is 7. Okay, well, you might say, okay, well, let's try 10 and 1. That product is 10, but the problem is 10 plus 1 is not 7. So that's not going to work. Remember, both conditions have to hold. But what about this, 5 and 2? Well, that is going to work. 5 times 2 we know is 10. 5 plus 2 is, in fact, 7. So because of that, we have 5 and 2 as those numbers would work, and we get this. I also did a check here, as you can see. Again, you just go through the calculation, and just direct calculation shows that what we did is correct. But once we know it's 5 and 2, we put the numbers in like so. That's all we're doing. Okay, that's good. That was fun. Let's do another one. Same idea, right? We have this kind of trinomial. There's 3 terms. The degree is 2. Okay? The leading coefficient's 1. Right? Remember, if a coefficient is 1, we don't write it. Okay? What's the matter? Someone have a, hold on. Someone have a, oh, I thought someone had a question. My mistake. Okay. All right. So we have to find two numbers, right, whose product is 20, but the sum is -9. Okay, but it's not, I'm just showing you, okay, well, would 10 and 2 work? Well, the answer is no, right? 10 times 2 is 20, but that sum is not -9. The sum is not -9. So 10 and 2 don't work. All right, let's try something else. 5 and 4, that product is 20, but it's not going to work either, right? The sum, remember, since we have a negative, you want to include negative as part of the number. Wait, let me get the laser thing. There we go. You want to include negative as part of the number, right? So B is actually -9. So 5 and 4 don't work because the sum is not -9. That sum is actually 9. But you can probably guess what numbers are going to work. -5 and -4. Right? By our sap and sun rules, the product is 20, but the sum is -9. So what do? So we can use these numbers and we factor it. And again, it's good to check, and that's what I'm doing here. Okay, so that's really good. Okay, so that's good. Okay, so let me see. I don't know if I really want to do that one yet. Basically, let me just say quickly, I mean, we'll do this next time because I don't want to get too far ahead of the other class. There we go. But here what's going to happen is, notice at first, this technique is not going to work. It looks like it won't work, right? Because our leading coefficient is not 1. But right away, you should notice that the GCF is not going to be 1, right? Because 2 is a factor of 24 and 40. In other words, you could factor out a common factor. We'll see that next time. So we'll stop here. And let me just, so are there any questions though?